Hey there everyone. Today we are going to be looking at how to solve these quadratics that we've been graphing. How do I solve the quadratic equation? So remember, when we're solving these, and when we solve linears, we were looking at the x-intercepts. Because remember, another word for x-intercept is solution. They're also known as zeros. And they're also known as roots. So those are all synonyms of an x-intercept. And in a quadratic, we talked about how many x-intercepts can I have. Well, I can have 2, because it crosses the x-axis twice. I can have 1, when it just hits the x-axis and then bounces right back up again. And that's also known as a double root. And then I've also got no real solutions. Notice how this graph right here never crosses the x-axis. So there are no real solutions there. So let's get into how do I solve these by graphing. So to solve a quadratic, the equation must be set equal to 0. And that's going to come in handy with what we're talking about next unit. All right, so we're basically, all we're doing is we're looking to find the x-intercepts. So instead of graphing these, we could use the ideas from standard form. We could find our axis of symmetry, and then we could plug it in. Or if we're trying to find x-intercepts, let's use Desmos. So like if I go to Desmos, and I type in, this function is negative x squared minus 3x plus 18 equals 0. Okay? So if I just graph this parabola, notice here, our vertex would have been way off our graph. Our y-intercept would have been way off our graph. But if I look just at the x-intercepts, I see that I get negative 6, 0, and 3, 0. So the solutions are negative 6, 0, and 3, 0. You might also see just x equals negative 6 and x equals 3. Both of those work. Alrighty? Let's look at our next one. So the first thing we got to notice is that this equation is not set equal to 0. So let's get it set equal to 0. And then this one I actually want us to practice using standard form. So I got x equals negative b, which is the 8, over 2 times a, which is 2. So I get x equals negative 8 divided by 2. I get x equals negative 4. So when I look at my vertex, I know that the x coordinate is going to be negative 4. And I can plot that AOS on my graph. So now I just got to figure out what happens when I plug in negative 4 into my function. So I'm going to plug that in, and I'm going to end up getting out 0, which means that this point, negative 4, 0, is on my parabola. Well, if that's my vertex, that's either going to be the highest point or the lowest point. To double check that, let's create a table. Now let's figure out what's going on. So we got negative 4, 0. Let's plug in negative 3. And then with symmetry, we know what happens when we plug in negative 5. So if I plug in negative 3, I'm going to get out, that's not right. Sorry. I'm going to get out 1. So that means when I plug in negative 3, I get out 1. Because of symmetry, I've got that point as well. All right, so we can plug in another point. We can plug in negative 6. And let's see what happens when we plug in negative 6. We get out 4. So when I plug in negative 6, I get out 4. Because of symmetry, I know it's over here. So this parabola is going to look like this. How many times as it crosses the x-axis? Only touches it once. So this is one of those things called a double root. So my solution is going to be negative 4, 0. Also, we could just say x equals negative 4. So that's our solution. We're just looking at the x-intercepts. Let's look at the next one. 2x squared minus 3x plus 5. So let's do this one on Desmos. So I think I already have these up. Oops. So I'm going to turn this one off. Let's first double check our last one. X squared plus 8x plus 16. The only x-intercept is at negative 4, 0. So there we're good to go. 2x squared minus 3x plus 5. If I graph that, you notice that it never touches this x-axis. So since it never touches that x-axis, it has 0 real solutions. We could also say no solution, because there's nothing that's going to work to make that cross the x-axis. You guys see that? All right, now let's go to our last one. X squared, 5x equals x squared plus 1. Well, I got to get this set equal to 0, so let me rewrite this. So I get x squared minus 5x plus 1. Let's do this the old-fashioned way. So I get x equals negative b over 2 times a. So I got x equals 5 over 2, so x is equal to 2.5. So let's stay with this one. So let's put our axis of symmetry here, in between 2 and 3. So to find my vertex, we've got 2.5. What's going to happen? Oops, I'm sorry. This should be set equal to 0. Let's see what happens when I plug 2.5 in for x. I'm going to get out negative 5.25. So I plug in 2.5, get out negative 5.25. So I got this point right here. So let's create an XY chart. Let's plug in 0. When I plug in 0, I'm going to get out 1, because that's going to be my y-intercept. And because of symmetry, I also know 5, 1 is going to be a point. So let's also plug in 1. When I plug in 1, I'm going to get out negative 3. So I get right here. So because of symmetry, I know that when I plug in 4, I'm going to get out negative 3. Okay, so if I graph this, I can tell that my solutions are going to be between 0 and between 4 and 5. So to figure out what they're going to be exactly, I'm going to go to Desmos. I think I typed in this equation wrong. Come on, computer. So I have x squared minus 5x plus 1. And you'll see that our x values, our solutions, are 0.209 and 4.791. So let's go back here. And let's say that our solutions the ordered pairs were 0.2090 and 4.7910, or we could say x equals 0.209 and x equals 4.791. All right? So what I want you to do right now is I want you to go to the uTry-Nows and try those two graphs, find those solutions by graphing, and then watch the next video where we'll be looking at how to find these things through a table.